What is VSEPR theory? When do we use it? And how do we use it? First of all, VSEPR is an acronym. It indicates valence shell electron pair repulsion. What does that mean? We know that electrons repel each other. So, valence shell of central atom repel each other and ultimately it forms a balanced, most stable shape. That's VSEPR. So theoretically, if we have two-dimensional diagram, we should be able to predict 3D shapes of any compounds using VSEPR theory. Let's look at an example. Here is a carbon dioxide. The first step is starting with Lewis dot diagram. As you can see, don't forget the octet rule. We have carbon at the center, 2 oxygen at each corner. Then we are going to highlight the central atom only. Literally anything around the central atom. Does it has any lone pairs? Or does it has any attached atoms? For this situation, we only have 2 atoms attached at the center. Now, we are going to convert into structural diagram. Don't forget that 2 shared electrons are the one that should be notated as a single bond. At this point, I'm going to use new symbols. I'm going to use A for central atom, E for any lone pairs around the central atom, and X for any attached neighboring atoms. Using those new symbols, I'm going to create the VSEPR shape. At this point, we have AX2 and we are going to call it linear shape. Let's use a simulator. So here we have a purple central atom. We are adding 1 and 2 neighboring atom. Look at the angle. We have 180 degree completely and is stabilized once that angle is achieved. So let's recap using the other examples. First step is Lewis dot diagram. Don't forget about the octet rule. Second step is converting into structural diagram. Third step, I indicate A, E, or X in each compound and provide a conclusive shape. In this case, both of them has AX2. If you know, you know.